as we have seen in the last videos that SIFT and also SIF and other matching algorithm, they use distance techniques. And also, even sometimes you have, of course, you have to ask yourself how the Netflix recommend TV movies for you, or how the buoyant recognize yourself. So this magic behind this technology lies in something like called distance matrices. So mathematically, tools that help computer understand how similar or different things are. So in today we are going to explore let's see just I would say four fundamental distance matrices that power many of the AI systems, and we use let's see every day. So think of this as different ways to measure distance between data points, just like we have measure distance between cities in different ways. And these matrices are, let's see, the building blocks of feature matching technique, which helps computer to find patterns, make a recommendation, and recognize objects. By end of this, let's see, video, I will try to give introduction about each distance matrices, for instance, Euclidean, Manhattan, Cosine, and Hamming. I will give a short, let's see, numerical example. This might be, let's see, trivial for some of you, but it might be also helpful for the other guys that have no experience with distance calculation. So fritz up, it's Euclidean distance, the most intuitive way to measure some distance. Imagine you are standing at a point A, and you want to reach point, for instance, B. And Euclidean distance is the simplest way that it's just simply a straight line path through these path between these 2 points. And the formula of where's the formula? Okay, see, I have just so this is the next slide. So as you can see here, it's for instance you have point from here to here. You just need to calculate the distance, and the distance is like x position minus the x point of the other point. For instance, you have an x, you are in, for instance, 2, 2. So x2 and y2. And let's see, b is, or q is 5, 5. And you will have to do minus, for instance, x1, which is 2, minus 5 power, plus 2 minus 5, because we have selected the same points. And this is for the 2D points. And if you have many features, let's say you have 1000 feature in this point. Let's say if you are you're measuring the descriptors of each endpoint, you will have to the first point from the descriptor, it's minus the first point in the second descriptor, and square plus the second point minus the second point square, and then plus until finishing the points. And when to use this Euclidean distance, sometimes we have seen we have used it in the SIFT and also SOF algorithm for matching, and also there are some others. Let's see, usage, for instance, physics, distance, image recognition, clustering, nearest neighbor, and also low dimensional data. So this is the Euclidean distance, and the Manhattan distance. It's the same as the. Let's say I will say it's the next. It's not a version. It's a version of the Euclidean. As you can see, it's the same but without squaring the point, the distance. It's just taking the absolute value of the difference. And sometimes you can see here. This is the Manhattan. Why it's called Manhattan? It's like the Manhattan city. So it's a measure of sum of absolute different values between coordinate. And you can see, for instance, difference is 4 minus 1, taking the absolute value is 3. And even if the difference is minus, of course, it will be uh, plus. So for instance, here's the point A and B. 1 minus 4, it will be minus 3, and the absolute value, it will be 3. You can also do it with the same, with the other one. It's 1 minus 4 or 4 minus 1, because we already taking the absolute value, this won't make any difference. So the distance between this A and B is 7 units. If we see this is the, let's see, the x-axis and y-axis. And we use this for city navigation, high dimensional data, feature selection, and also outliers detection. Outliers detection, for instance, you have this object here, and you will see if the other object has a distance more than a specific threshold, you can see its outlier. Its outlier. And next is the cosine similarity. So this cosine similarity is measure similarity in a completely different way by looking at the angle between two vectors. And sometimes Euclidean distance on Manhattan, it's not, let's say, giving correct or efficient way. So if you see the distance between 2 points, maybe it's not relevant, or maybe it's not a good metrics to use. So cosine similarity is solve these issues, and you can see the difference between the range is from -1 to 1. So if the result is 1, it has the same direction. If it's 0, it's perpendicular. It's If it's opposite direction, it's uh, 100. I mean, it's opposite direction. So you can see, for instance, this one here. If if the angle is maybe it's 1 close to 1, or you can see angle 0 close to 0, cosine, then now you can see these are the similar direction. If it's like this, it's perpendicular. You can see it's orthogonal. And this here is, it has a different, it has -1 similarity. So you can see they are in the different direction. So this is A times B divided by the absolute of A. I mean, not the absolute, the dot product of A are and the magnitude. And let's see if, for example, we have this example here, x and y. So the dot product is 3 times 1 plus 2 times 0 plus 0 times 0 and plus 5 times 0. So the distance. Let's see, the dot product is 3. Now it's divided by magnitude of x times magnitude of y. So that magnitude is squaring all of these values in for x and also for y. So the cosine similarity is zero point 0.4. So the cosine similarity is close to, not to 0, not to 1. So let's see, we can see it's perpendicular. So you can also see if it's the threshold, for instance, is this one here, and you can see there's a similarity in this. For instance, if I see if the cosine similarity is greater than zero point 0.7, I will consider it as similarity. And you can see it's mainly it's designed to calculate the distance between vectors of words. So text analysis, recommendation system, uh, information retrieval. I mean, I will see it's used for text, but of course it's used for many applications. And the Hamming distance, though, if you remember that, we have also seen how ORB algorithm is working for the calculating the matching. So it's using Hamming distance. The Hamming distance is measuring the number of position in which corresponding elements are different between two binary of equal length. So here we have to have the equal length. So you can see this is the difference. It's we count with the x and y are not equal. So this is the distance. For instance, let's see here this example, A and B. So we have similarity here. This is not similarity. There's no similarity because 0 here and here's 1. And 0, 1 is a different. 0, 1 is also different. So the number of differences are 3. So the Hamming distance is 3. So this is used in a in a ORB algorithm. So because it's super easy and also more efficient if you calculate the distance of just differencing. I think that's enough for today. And if you have any question, just drop it down in the comment below. Thanks for watching and see you next time.